All right, so part two is momentum. All right, momentum. So momentum is the quantity of motion. All right, and what I mean by a quantity of motion is that if you have more of this, then when we look at the results of an interaction with something else, if those interactions are based on how much motion you have, then if you have more of this quantity, momentum, you'll have more of those effects. And it took a long time to do this. This is something Huygens did. He went around and he slowly hit balls and things like that, little rivers running down streams like they have in Holland, I think. And he discovered that this quantity of motion is the product of the mass and the velocity. And so P is the momentum. I don't actually know why momentum is called P. Actually, in old textbooks, it's called M, which would mean you have M equals M times B, which would really freak you out, which is probably why it's called P. So that's part A. So that's the basic definition. How would this work? What sort of things could you say here? Well, let's say I have a bowling ball, right? And it's 20 pounds. And it rolls down the lane at 15 miles per hour. Then what would the momentum of the bowling ball be? Big old P here. It would be 20 pounds times 15 miles per hour, which would be 300 pounds of mass times 15 miles per hour. Now I'm using pounds of mass because this is mass, not force. We're not at the point we have to care about that. So that's the momentum for the bowling ball. Now, if I take something smaller, like a baseball, let's put things here, it's going to go really fast. Let's say it's pitched at 90 miles per hour. A baseball weighs about 5 1/4 ounces, which is just about 1/3 of a pound. So we'll use little p is equal to 1/3 of a pound times 90 miles per hour. Right? So that's going to be equal to make it minus 90 miles per hour because it's going to the left. So that's going to be equal to minus, cancel one of the 3's and the 9, 30 pounds of mass times miles per hour. I really wanted that to be larger than this one, but that's just not the way it is. Bowling balls have more momentum than even the best fastballs. So an average bowling ball, this is not really fast for a bowling ball. This is reasonably fast for a baseball. Okay, so that's how that is. So what we're looking at is we're saying that because of this definition, something that's really heavy could have a small velocity. Right? In this case, we've got 300 versus 90. If we divide by 10 and multiply by 3, so let's see. This we're going at what would be 4.5 miles per hour. Then it would have the same momentum with something with a small mass and a big speed. All right, so large mass times small velocity is equal to small mass times a large velocity. Okay, and you can think about it a little bit like this. We've got a big mass here, small speed here is equal to a small mass here the big speed there, right? These things have the same area. All right, so that's more or less what goes on with momentum. Big things going slow have the same momentum as a small thing going fast. That's more or less it. Mass times the velocity. So we're pretty good with that. So again, this guy has to go really slow. A bowling ball, a 20-pound bowling ball is a lot heavier than a 5-ounce baseball. So it has to be going really slow, like we said, 15 or 4.5 miles per hour to have the same momentum as a baseball. But that's much slower than what you actually get on the lanes. Trying to think if it's a good idea. It's probably a really bad idea for you to try catching baseballs. And baseballs, probably it's okay to catch them. It's probably really bad to try to catch bowling balls. So don't do that. Do not catch bowling balls in your spare time. I'll talk to you in a second about an example.